Welcome to aminacademy.com. In complex analysis, let us discuss about the elementary complex functions. In mathematics, an elementary function is a function of a single variable, typically real or complex, that is defined as taking sums, product, roots, and compositions of finite many polynomials, rational, trigonometric, hyperbolic, and exponential functions, including possibly their inverse functions like arcsin or cos, that is sine inverse tan, sine inverse x, tan inverse z, like lot of functions together is called elementary complex functions. And that we'll discuss one by one shortly. First, polynomial function. Polynomial functions in general is w equal a0 zn plus a1 zn minus 1 a2 zn minus 2, like it continues. Then a n minus 1 z plus an, which is equal function of z, where here a0 is not equal to 0, as well a1, a2, a3 up to an are the complex constants. Complex constants, n is a positive integer called degree of polynomial, where n equal positive integer, which is called degree of the polynomial. Degree of this is a polynomial functions. So that means a1, a2 are the complex constants. It can take any values of complex number, and n is a degree of that particular polynomial functions. Next is rational function. Here, the rational function, we know that rational is division of two functions, where w equal rational function p of z over p of z. P and z are functions of z. P of z and q of z are functions of different functions of rational algebraic functions. Here, now in particular cases, we can write w. We can say w equal w equal az plus b over cz plus d. Here, where suppose it's a conjugate, we are finding this cz plus d, the conjugate is cz minus d also can write. Then here ad minus bc is not equal to 0. ad minus bc is not equal to 0. After simplification, this expression, that is ad minus bc is not equal to 0, is often called linear or fractional linear transformation. Fractional linear transformation. Next is exponential function. Here, w equal a power z, where z is a complex number. It can express, z is expressed as x plus iy. Further, we can write, which is e power x into cos y plus I sin y also you can express. Here, where e is the natural base of logarithm len and a is a real and positive. Therefore, we can write one more example. A z equal e power z len a. A power z we can write as e power z len a. A is any normal base and e is a natural logarithmic base. Conversion is this one. Here, where this reduces to if a equal to e, the complex exponential functions have properties similar to those of real exponential function. For example, e power z1 into e power z2 is e power z1 plus z2. E power z1 division e power z2 equal e power z1 minus z2. Then because it is addition rule, it's multiplication rule. Next one, trigonometric function. Trigonometric complex functions are sin z. We define the trigonometric or circular function sin z cos z in terms of exponential functions as follows. Sin z equal e power I z minus e power minus I z over 2i. Then cos z is e power I z plus e power I z plus e power minus I z over 2. Tan z equal to sin z over cos z, that is here e power I z minus e power I z over e power I z minus e power minus I z over cos is e power I z plus e power minus I z. It is expression of tan z. Here for sin is reciprocal is cosecant. Cosecant z equal 1 over sin z, which is equal 1 over sin z. After writing the reciprocal, we have 2i over e power I z minus e power minus I z. Then secant is the reciprocal of cos. Secant z is 2 over secant is 2 over e power I z plus e power minus I z. For tan is cot. Reciprocal is cot z equal cos z by sin z, which is equal I into e power I z plus e power minus I z over e power I z minus e power minus I z. This is a 6 basic trigonometric functions in complex number. Now some special identities regarding complex trigonometric complex is, for example, look at here. This is sine square z plus cos square z equal to 1. 1 plus tan square z. We know that it is secant square z. 1 plus cot square z equal to 1 plus cot square z equal cosecant square z. Now minus functions like sine of minus z equal sine of minus z equal to minus sine z. Like same cos of minus z equal cos z. Now tan of minus z equal to minus tan z. Next is addition of this further addition formulas also. For example, sine of z1 plus or minus z2 equal sine z1 cos z2 plus or minus cos z1 sin z2. Like same for cos of z1 plus or minus z2 equal cos of z1 plus or minus cos z2 equal to cos z1 cos z2 minus plus sin z1 sin z2. From this tan also you can find z1 plus or minus z2 equal tan z1 plus tan z2 over 1 minus plus tan z1 tan z2. Here these are some basic identities. Now next one is hyperbolic functions. Hyperbolic function is h will come, that is here sin hz equal, in terms of hyperbolic, e power x minus e power minus x over 2 cos hxz. Cos hz is 1 over cos hz is e power z not x, sorry, e power z power x plus e power minus z over 2 tan of tan hz equal sin hz over cos hz, that is e power z minus e power minus z over this. You want to cut e power z plus e power minus z. For reciprocals, sin h is cosecant hz equal 2 over e power z minus e power minus z. Same for cos hz equal secant hz equal 2 over e power z plus e power minus z. Cot hz equal e power z plus e power minus z over e power z minus e power minus z. Here it's better to remember these identities. That is why I wrote the same things to for you it is easy to remember. If you rewrite one more time yourself, we can keep it in mind. Here the same some identities, further identities we can do. Look at here, cos h square z minus sin h square z equal to 1. It's a basic identity for complex trigonometric functions. Then 1 minus tan h square z equal secant h square z cot h square z equal cot h square z equal cot h square minus 1 equal cosecant h square z. Now same like a plus b also here. Sin z1 plus z2 cos z1 plus z2 tan z1 plus z2 also you can express. Better to write that also. Sin of h sin of h z1 plus or minus z2 equal sin h z1 cos h z2 cos h z2 plus or minus cos h z1 cos h z1 into sin h z2, or same for cos h z1 plus or minus z2 equal cos h z1 cos h z2, this comes opposite, which is same plus or minus sin h z1 into sin h z2. Same for tan z1 plus z2 equal for tan of h z1 plus or minus tan h z2 over 1 plus or minus tan h z1 tan h z2. Next is minus functions, like here sin of h minus z equal to sin of h minus z equal to minus sin h z, cos of minus z, cos h of minus z equal to positive cos h z, tan of h z, tan h of minus z equal to tan z minus tan z. Here further discussion about identities. Look at here, sin of iz equal I sin z. Remember this, I comes front. Same sin h a sine hyperbolic here. Sine h of iz equal to I sine hz for cos h iz equal cos hz. Cos h iz equal to cos z. It is not coming. Remember, this is a normal trigonometric cos z. Tan iz equal I tan z. I tan z. And cosine. Same for cosecant. Cosecant iz equal to cos tan. Here, something you have to correct it here. Here, first is sine iz. Sine iz equal to I sine hz. Cos iz. Cos iz equal cos hz. Cos iz equal cos hyperbolic. Cos hyperbolic z. Tan iz equal I tan iz equal to I tan hz. Remember here, your normal function sine iz equal I sine hz hyperbolic. Cos iz is hyperbolic cos hz. Tan iz normal. Here I tan hyperbolic z. Next is logarithmic function. If z equal e power w, then we can say w equal to, take len both say, w equal to len z. It's called a natural logarithm of z. Thus, the natural logarithm function is the inverse of the exponential function and can be defined as, now w equal to len z, which is equal len r plus I of theta plus 2k pi, where k is an integer. K is plus or minus plus 0, plus or minus 1, plus or minus 2, like it goes. Here, where z equal to e power, where z equal to e power I theta in polar form, which is equal r into e power I theta plus 2k pi, where note that len z is a multiple valued function, where len z equal multiple valued function. With interval length 2 pi. Now, next is inverse trigonometric. For inverse trigonometric also applies here. Look at here, sine Inverse z is a normal inverse which is equal 1 over I ln iz plus root of 1 minus z square. There, then cos inverse z equal 1 over I ln z plus square root of z square minus 1. Remember this. Tan inverse z equal 1 over 2I ln I plus 1 plus I z over 1 minus I z. Same for reciprocal, that is cosecant inverse z equal 1 over I ln I plus z square minus 1. Here sin inverse z equal to 1 over I ln I z plus 1 minus square root of 1 minus z square. Here is z square minus 1 over z. Cosecant, then secant inverse z equal 1 over I ln 1 plus 1 minus z square over z. Cot inverse z equal 1 over 2I ln z plus I z minus I. So these are, you have to remember, this little complication is there, but you have to remember this. Next, inverse hyperbolic function. Here inverse trigonometric function, here inverse hyperbolic functions. For this, same, sin h inverse z equal to ln z plus square root of z square minus 1, z square plus 1, cos h inverse z equal ln z plus square root of z square minus 1. Now tan h inverse z equal 1 by 2 ln 1 plus z 1 minus z. Then reciprocals, cosecant h inverse z equal ln 1 plus square root of z square plus 1 by z. Secant h inverse z equal ln 1 plus square root of 1 minus z squared by z. Cot h inverse z equal half ln z plus 1 by z minus 1. Next, multiple valued function which is equal, suppose, where suppose z power alpha where alpha may be a complex is defined as e power alpha ln z. Similarly, f of z, g of z are two given functions. Then of z, we can define f of z into g of z, power g of z equal e power g of z ln f of z, ln f of z. In general, such functions are multiple variable. Next, algebraic and transcendental function. If w is a solution of a polynomial equation, then p of 0 of z w power n plus p of 1 of z w n minus 1 plus dot dot plus p of n minus 1 of z w plus p of n z equal to w, where p of 0 not equal to 0 and p of 1 z or polynomials in z or polynomial in z variable. Then this is called a transcendental functions. Now so far we discussed and wrote a lot of functions and its expression. We have done. Please subscribe our YouTube channel.